Today you're going to watch a video on different types of inequalities, specifically compound inequalities. We've already looked at less than, greater than, less than, equal to, greater than, equal to inequality signs. We've solved multi-step inequalities. So I'm going to continue with what we need to be successful. All right, so compound inequalities, there's two types. The first type involves and. This would be a good time to pause and get the definition of and compound inequalities. And compound inequalities contains the overlaps of graphs of the two inequalities that form the compound inequality. So for example, here we have the first inequality, all real numbers that are greater than or equal to 3. And the second inequality, all real numbers that are less than or equal to 7. Here, this green example here, this one shows you the solutions that are true, and it just makes it neater. It's easier to understand. So everything here in this interval makes this statement and this statement true. Here, if you notice in the blue example, everything to the left of 7 makes just this inequality true. For the red example, everything to the right of 3 makes just this inequality true. But again, the green example, let me erase some of this. The green examples shows just what's necessary here to make both inequalities true. That is and, where it shows what is true for both parts of the inequalities. So let's just do an example. All real numbers greater than -2 and less than 6. So remember, open circle, when it's no equal to sign underneath. I'm just graphing, and when I shade in the direction of the inequality sign. So here it's going to the left, I shade to the left. Here it's going, or excuse me, to the right, I shade to the right. Here it's going to the left, I shade to the left. So that means all the numbers in between -2 and 6, not including -2 and 6 because it's an open circle, will make the inequalities true. Let's continue. Why don't you pause the video here and try this example number 2 for yourself. Keep in mind, all of this should be in your notebook. All real numbers that are greater than or equal to -4, greater than or equal to -4, and less than or equal to 3. If I graph this, I already know I have, oops, there's a graph already. I already know I have both closed circles simply because the less than, or excuse me, the equal to sign is underneath. So if I graph this, closed circle here at -4, closed circle here at 3, and I am shading all the way from one point to the other on my graph, meaning all of these numbers in that interval makes the statement true for both inequalities. Well, it's not always going to be that easy. Here is an example where you're given what are the solutions of -3 less than or equal to m, -4 less than or equal, or excuse me, less than -1. Here, and this is what you'll see, is a compound inequality that needs to be it needs to break apart. You need to create two equations from this one entire statement before we can know how to graph and what solutions will make the inequality true. So what do I mean by breaking these equations apart? I see this first part and I see this second part. And those are my two inequalities that overlap. So let's give it a try. -3 less than or equal to m minus 4. I add 4 to both sides. I get 1 is less than or equal to m, or m is greater than or equal to 1. Usually we like the variable first. My second equation, m minus 4 less than -1. I add 4 to both sides. M is greater than 3. Here I have a closed circle at 1. Here I have an open circle at 3. And I am shading the numbers in between these two that will make the entire inequality true. I hope that makes sense. So let's do another example. Here, one equation. Here, second equation. These are pretty basic. Divide by 3 to get y by itself. -1 is greater than y or less than y. Excuse me, -1 is less than y or y is greater than -1. Keep in mind when you put the variable first, you just flip the sign. Here I'm dividing by 3, so y is greater than 4. To graph these, both open circles, -1 and 4, all of this in between makes the statement true. Those are and examples. Well, some inequalities contains or. Here's a good place to pause the video and get the definition of an or compound inequality. I will continue. Or contains each graph of the inequalities that form the compound inequality. Or mean they don't overlap. Many numbers can make the statement true. So here is an example at the bottom, the red one, the first inequality. Open circle, everything to the left till -infinity makes that statement true. The blue example, x is greater than or equal to 1. Everything to the right to infinity makes that statement true. So when you combine these two, which is the green example, or all real numbers that way, all real numbers that way. No overlapping. Or means infinities, positive, negative infinities, and means they overlap. So let's look at an example. All real numbers less than 0 or greater than or equal to 5. Or, that word or lets me know they are not overlapping. So I have an open circle at 0. Ooh, excuse me, that's a mess. Let me fix that. I have an open circle at 0, closed circle at 5, and this continues on to infinity here, and this continues on to infinity here, meaning -1000 makes the statement true. Meaning positive 100 makes the statement true. Or examples. Or. Let's try another one. Are real numbers that are less than or equal to 2.5 or greater than 6. I'm sure I have a graph down here. Yep. So how would I graph this? Open circle at 6, closed circle at 2.5, graph to the direction of the inequality sign, and that means all the numbers to infinity here, or negative infinity here, all the numbers to positive infinity here will make this statement true. So let's continue some examples. You try this. Here's a good time to try this in your notebook. Pause and see if you get it. I am going to continue. Got 2, so I know it's an OR problem. Subtract 2 on both sides, I get -9. Divide by 3, and I get x is less than -3. Here, subtract 5 on both sides, and I get 2x is less than -4. Divide by negative, so my sign flips, and I get +2. Immediately, I see that my signs, my inequality signs are going in opposite directions, and that's what we want. So I'm off to a good start. Open circle at -3, shading in the direction of the inequality sign. Open circle at +2, shading in the direction of the inequality sign. Here's another one we can try. Get these again in your notebook. Add 7 to both sides, and I get 2y. -2y is less than 8. Divide by -2, so the sign flips. Oh no, I did that wrong. Let's see. Sorry, let's back up. If I subtract 7 on both sides, I get -6, right? Yep. Divide by -2, and the sign flips, and I get +3. Here I subtract 3 from both sides, and I get -8. So y is less than or equal to -2. My signs are going in the opposite direction. Close circle at -2, shading to the direction of the inequality. Open circle at 3, shading in the direction of the inequality sign. Last couple of things for you to understand: interval notation. When you have and, you do not use sets. You just use notations, and I'll show you what I mean. When you have less than, equal to, greater than, equal to, you use brackets. When you have just less than or greater than, you use the parentheses. And problems, you have only one set. Or problems, you have 2 sets. And it makes sense you have 2 sets because you're going in 2 different directions and you use infinities. So let me show you what I mean through an example. What are the solutions of an and problem? Because I don't see any separations. So I have to create my 2 equations with my and problems. And here they are. They overlap. So -3 less than m minus 4, m minus 4 less than -1. When I solve it, I get 1 less than or equal to m less than 3 for both sides. Well, I want my variable to be first, so I'm going to switch and say m greater than or equal to 1. I have a closed circle at 1. I have an open circle at 3, and I graph so that they come together. It's an and problem. My interval notation, because my first number was greater than or equal to, I use a bracket. Put the first number there, comma. My second solution is 3, and it's an open circle, so I use parentheses. And that is interval notation. Try this last problem in your notebook and see if you get -infinity, -3 as the first notation. Again, with and problems, 1 set, or problems, 2 sets. And you should have that. Keep in mind going all the way to -infinity on one side, all the way to +infinity on the other. Now it's time for you to practice.